Okay, so now we're going to give you guys basically a run through of how to build a binary tree in Bridges. And so Bridges was originally developed. Bridges is a project by UNC Charlotte, and the people who do it are great people. I like them a lot. They're wonderful. They're fun to hang out with. And it was originally developed as a data structure visualization tool. So it was designed for this class, for CSI 41 or whatever the number is at Charlotte. And so if you look at the documentation, so if we go over to the Bridges main page, let me copy and paste this onto Discord for you guys here. And you gave them bad reviews. You should not give them bad reviews. I mean, you can do whatever you want, I guess. I mean, that's the whole point of a review system is you give your feedback. I like them a lot. So, I know students that get A's a lot of time have a hard time adjusting to the industry because the environments are very different. Yeah, that's true. So if you go over to the Bridges website, you'll see that there is a reference section. And you want to click on C++. No, not that one. Sorry. Client source codes, documentation, sorry. C++, API, no, not that one. Tutorials, that one. Okay. And then we're going to go to binary search tree under trees. And if you look at the things that they did, they're all basically CSI 41 stuff with the exception of graphs. So you've got these various trees, you got these various lists, and then I think they also have like an array somewhere that's not listed here. Arrays are pretty boring to visualize them. So it's mostly like linked lists and trees. That's like the core thing that they were interested in visualizing. Graphs are a CSI 26 topic, and so you're going to be using Bridges in CSI 26 to visualize graphs in that class as well. And one of the core abilities you need to develop as a computer science major is the ability to take demo code and adapt it to your needs. So if you just told me just use Bridges and make a tree, I'd be like, I don't even know where to begin, dude. Like if I looked at what I misclicked on last time, if I clicked on this and I clicked on show me the list of all the classes, and I'm like, oh my lord, there's a lot of classes here. There's an input helper. I don't even know where to begin, right? Like tree maybe. BST element, let's click on that, and it's got this thing here, and I'm like, I don't know, dude, it's got these things. Like, I don't even know where to begin. Like, what do I put first? What do I do? You know, I need demo code, right? And so one of the core abilities of a computer science major is to find demo code that is close to what you want to do and adapt it to what you need it to do, especially the first time you use something. Like I've used the CImage library, which can open JPEGs and PNGs and things like that a number of times. And so I'm pretty good with it now, and I don't need to really look at demo code anymore. I can just work with it directly. But like when you're learning something, man, that demo code is crucial because otherwise you just have a list of functions. You're not really sure what order they go in, like, or what values they can take. Like, you know, are you taking a number from 0 to 1? From, you know, like if you're doing colors, like does this take a number from 0 to 1, from 0 to 255? What is it supposed to look like? Okay. And so fortunately though, they have tutorials because they're, like I said, they're awesome people. They have tutorials for everything. And so this should look pretty familiar to you. This is a binary search tree, right? Their terminology is slightly different from what I use. I call the values being held at each node data. They call it key because it is a key. A key is something that you use to search a data structure for. So if you have a database and you're going to be searching a database for a person, whatever you search the person on is the key. And so what do you guys think that most databases, like for our college, like when somebody looks up your information in the computer, what do you think they type in as the key? You had to guess. The database system. ID number. Yeah. Your name could be a duplicate, right? And one of the two requirements for a key, for a good key at least, is that it's unique, no duplicates, and it has to be sortable. You have to be able to have a less than operator on it. And so an ID number is great for that. Every student is given their own unique ID number, and there's no duplicates. If you had duplicates, I don't know what would happen. You'd probably erase the existing student in the database. Name, you could look up on name, but what if there was another, Megan Eggert in the system? This happened in my high school all the time. There were two Jose Oteros. One of them was, he's now actually an astrophysicist, PhD from Caltech, and the other one was a hoodlum. And so the good Otero, Jose Otero, kept getting called to the principal's office. He'd get pulled out of class, go to the principal's office, and he shows up, and they're like, "You're in big trouble." He's like, "You wanted the other one, right?" Okay. And so the office had to write down, there are 2 Jose Oteros in this school. Make sure you're sending to the right one. Yeah, so names don't really work that well. But if you do, then oftentimes they'll do something like W. Kearney, and then if there's another W. Kearney, it's W. Kearney 2, W. Kearney 3, and so you create kind of a unique key based on first name, last name, then an optional number on top of it. And if you're the U.S. Kennel Association, did I tell you guys this story? And he wasn't a hoodlum. I played soccer with him. He was actually a great guy. I liked him a lot, but he got into trouble a lot. Let's put it that way. He was not sticking up banks. He was just a fun-loving teenager. Maybe too much fun-loving. I don't know. But did I tell you guys the story about the American Kennel Association? How they were storing dog names as the key? So the American Kennel Association, every name of a dog should be unique, but oftentimes they're not, right? So there's probably a number of Rexes or whatever. And so the way the American Kennel Association worked was if you registered a second Rex with them, it would be essentially Rex 2. And the system worked fine until there were 17 dogs with the same name. If you ever tried registering a dog with the same name that would be Rex 18 or whatever, it would crash their system. It only worked up to 17. And the reason, and you're like, why 17? That's a really weird number. And the answer is because they were holding Rex 17 as Roman numerals. So they had a fixed size generation number or whatever you call it, clone number, I don't know what you call it. And so if you entered a second Rex, his name would be Rex, and his clone number or whatever would be II. It would not be the number 2, it would be II. So he'd be Rex, Roman numeral 2. And then you register another Rex, and it's Rex III. And you register another one, it's Rex IV. And that works all the way up to 17, which is XVII. It was a fixed 4-character long string for holding the clone number of the dog, or whatever you call it. If you go to 18, that's 5 characters. It overflowed and crashed the system. So if you guys ever feel like imposter syndrome about like your coding abilities, just remember the American Kennel Society would only allow you to have 17 dogs with the same name ever. And after that, it would crash their system. So you think your code's bad, then you go into the real world. You're like, oh dear, I see how it is here. That's not good. So there are some pretty fantastic bad codes out there. Okay. I don't know why they use Roman numerals. I imagine it's so that like when you send somebody their ID card, it's like you have Blue Sun IV, or something like that. So it looks fancier, and they just decide to store it as a Roman numeral rather than as a number and have to convert it to Roman numerals later. And I guess they just figured we're never going to have 17 dogs with the same name, let alone 18. So let's just set a limit of 4 on it. So the professional created this website I hate. I can definitely get a job as a developer. Yeah, exactly. So so the keys for a database are what you use to search a database. And you'll even see it in it'll say ID parentheses primary key. And that's what you typically use to search a database for students. You use their ID and it'll go through a binary tree usually, and it'll find the record. And then the value that's associated with this is typically a record somewhere. And you'll pull up, name, address, social, all that kind of stuff. And if you wanted, you could have 2 different keys in a database, but now you've got 2 trees, right? So you have to be kind of judicious with how many secondary keys you have in a database, because every time you allow searching on a new column, like address or whatever, you have to make a whole other BST on it, and that doubles the amount of RAM you need and all that kind of stuff. So you have to be like, when you're doing database stuff, that's like one of the things you think about. It's like, what do I want people to search on? And if you try searching for something that you don't have a key for, like if I try searching for Parmesan, Aaron's fake last name, if I try searching the data structure for Parmesan and the key is student ID, I just have to go through the whole thing, right? Like I just have to go and iterate across the entire thing and until I find somebody whose last name is Parmesan. And that's like how I assume the DMV works, because it takes them minutes to find a person by name when they're not searching probably for the driver's license, probably their primary key. So when they punched in my name to find me, I stood there for 5 minutes waiting for them to do an order in search, probably, instead of an order login search, which is instantaneous. So it is his fake last name, I think, right? Yeah. Okay. And he's still Mr. Parmesan for now. He'll be Dr. Parmesan in the future. So they call it a key for that reason. Okay. But otherwise, exactly the same thing. It's got a left pointer, a right pointer. Pretty basic binary search tree. Okay. We come down here, and we're going to go to BST element here. Boom. And no, that's actually the documentation. Let's see. Scroll down here. Okay, there we go. C++. And so you can just sit there and copy and paste. And I'm not going to give you the source code. I'm going to let you guys go through this process yourself. So follow along at home. So I will give you guys the link here. We can find the tutorial. And go ahead and drop this into somewhere on the server. This is what you're going to be using to, probably in your Dungeon Delve directory. Just don't overwrite your existing one. So I'm going to just put in a file called bst.cc. If you wanted to, you could integrate it with your Dungeon Delve code. That's fine too. And so let's go through here. And instead of including string, I'm going to include /public/read.h. Do you guys know the difference between double quotes and single and the curly braces kind of things? You guys know the differences between these? So a angle bracket is a system installed directory. So this only works if somewhere within the official system administrator me installed directories is there a file called bridges.h. And in fact, if we locate bridges.h, you'll see that inside of the /user/include directory, there is in fact a file called bridges.h. So we can actually use the angle brackets here. Angle brackets work. And double quotes work too. Double quotes will look in the official directories and in your local directories. So that's what a double quote means. But these are installed in the official system, include directories. And so we can actually make these angle brackets. Double quotes work too. I have to use double quotes for this because this is not in the official directory. This is just in /public, which is not a official include directory. And so anytime you make your own .h file, it's going to be using double quotes. Anytime you use a system library, normally IOStream and things like that, but I've actually put the bridges code into there against my better judgment, but it just makes life easy. Using namespace standard, using namespace bridges. So do the bridges people use using namespace standard? Yes, they do. Suck on that, UC Irvine. Okay. So one of my students went to UC Irvine and used using namespace standard, and the professor sent him a link to a 5-page long screed that he wrote about the evils of using namespace standard. And I just thought it was funny because, honestly, for a small project, it's fine. It really is. The only time using namespace standard will trouble you is if you're using multiple libraries all at once and they have a namespace conflict. Like you have a file that has function A and another that has function A, and they're different, then you'll get in trouble. And so in that case, what you do is this: you just delete it. You're fine. It's not a big deal. All right. So project ID, I'm going to call this one 412. My user ID is wkearney. My API key, it's like my password, so I will scroll this off the top of the screen. And then come up here. And if you want to get your API key, it is under login. And then if you go to profile, it'll give you your API key. Grab that real fast. And I'm probably going to expose it anyway during this talk, so I'm going to reset my API key anyway in a second. Save. Okay. Stop over here. Okay. And so what we're going to do today is basically something like this, where you're going to make a visualization of one of your dungeons. And what I want you guys to do for this is for what you turn in on part 2 on Friday, you'll probably do today, is visualize your name. Make a dungeon out of your name. Obviously, any duplicate letters like L for me get deleted because it's duplicate. Okay, so this is a binary search tree. I could put arrows on it if I wanted, but I don't care that much, so it's fine. All right, so then let's take a look at the source code. So this is how experience. Oh, there's my API key. It's all right. I'm going to reset it anyway. So the demo code, right? You start with demo code and you look at it, you understand it, and then you modify it and you make it your own. This is how computer science works. Like really, like when you want to understand a new thing, this is what you do. You find demo code, you modify it. So I'm going to change the title to be like Dungeon Build Part 2. Again, in Roman numerals because I want to be like the American Kennel Association. Don't send the dogs after me. Description, visualization of a dungeon. We will create the tree manually. Yeah, cool. All right. So you find it hilarious the way I constantly throw shade at certain things. Who am I throwing shade at? They're throwing shade at me. Okay, so and then we come down here and they're deleting all these things and return 0 and get rid of that. Okay, so the key thing here is search bar in Unreal Cyberpunk. I mean, yeah, fair enough. Yeah, I don't think I'm too out of line on those. Like Cyberpunk was a pretty buggy game at release, and the broken search in the Epic Game Store is also pretty well known. Okay, Geeks for Geeks, yeah, true, very true. I got opinions. Okay, so what we got here is some demo code, and they are creating a. It looks like they're doing a map, not a set. So a map has, hey, if you can't handle me at my worst, you don't deserve me at my best. No, honestly though, like most of the debates that people get into, like I don't care about. How do you capitalize a variable? Things like that. So, so what they have here is a map. So they're mapping between an integer, which is being used as the key, and a string, which is what it's going to visualize on the labels on the visualization. Okay, and so they're creating a bunch of nodes by hand. We're going to do this like professionally, proper like debates between spaces and tabs. Yeah, like okay. I have a lot of opinions. So let's go ahead and get rid of all these. I don't need these. I'm going to leave a little bit of demo code behind. This just so I can kind of see what the functions are called. I'll leave this behind. Okay. There. Okay. Up here. All right. So we're going to start off by doing something like this. String name is equal to read, please enter your name. And so the that'll type in Bill or whatever. And then I'm going to make the tree a mapping between, I guess, a character and a string, maybe. Character and a character, maybe. Now, you might think it a little bit odd that I'm having to type char and char twice, right? So is there a way in C++ that I can avoid typing out this kind of ridiculously long type name every time I type something? And the value will be name.at0. Is there a way that I could avoid typing all this stuff here? I am using templates. That's what's going on. How can I avoid typing all of this here? What can I type here instead? One word. 4 letters. 4-letter word. Auto. Boom. Yep. So auto ta. Right. So anytime you have a long type name, like you'll see me sort of not want to type it twice. So here is already done for me, but still. Okay. And I'm going to be doing name.at0. Now there's a possibility that we don't have a first character. This should pretty much ensure that we always have a first letter. If we wanted to be safe, we could say if name.length is less than 1, die. We'll do it properly. Okay. Cool. One thing I learned at SIGC, let's see out name.at. Okay. Actually, let's use square brackets. What's this code going to do? What do you guys think? Is this code going to crash? It's going to segfault? I'm now putting the 11th letter in my name. Is it going to work fine? Yes? No? Crash? Die? Sometimes? Yeah, because my name could be 10 letters long. Like it could be John Jacob Jingleheimer Schmidt, right? It's more than 10 letters, I think. I haven't counted. Might go out of bounds. Why not? Let's find out. Let's compile them. BST.cc. And it's going to give me a linker error. LD is the linker. And if you see all these functions in the curl library that are not found, that means I did not link a library in properly. And so you do -l curl like that. Look at that compile time. It's super fast. Super fast. And there we go. And if we run it, type in your name, Bill, and you can see the 10th letter in my name is close curly brace, as if Elon Musk was my father. What if I do element 100? What do you guys think? I type in Bill again. Good thing I'm going to get. Think we're in segfault territory yet? Worked fine. Printed out blank. So when you go out of bounds like that, it's undefined behavior. It's unclear. Like you don't really know in advance what it's going to do. Now, at SIGC, I learned about a new compiler called BCC++, which is experimental and doesn't work very well in C++. They made this wrong one. But I'll show what happens. When you go out of bounds, it actually changes it. It's this really cool tool. It's actually very similar to what I do for you guys with like G++ and the aliases and things like that. They do the same thing, but they bake it all into one executable. And then when address sanitizer explodes, they actually catch the output of address sanitizer and change it to make it readable, which is really cool. So you can see here that rather than getting that normal thing like -f .cc -f sanitize equals address .cc. So normally you get this stuff. Fa. You're like, what the hell is going on? This is a heap left red zone. What is that? Global red zone. I don't know what that means. Poisoned by user. Oh, Lord, that's crazy. Like all this stuff that like nobody understands except, highly technical people. What they did is they just made it readable. So they actually check the output of address sanitizer, and then they make it readable for students, which is really cool. It's a neat project. It's made by, I think, University of New South Wales or something like that in Australia, and it's human readable. So that's pretty cool. The trouble is the C++ version of it always ends with like broken pipe, and there's other problems that I've encountered with it. So I'm not going to make it standard just yet. You can see that they've got, it'll link you to a place where you can read more about, the mistake you made. It shows you main.cc, line 9, did this. They give you a little explanation. You accessed out of bounds. Make sure you've allocated enough memory for the size of your structured array. Common errors use, And so if we do this with our BST code here, then we're going to go linker error again. Clang error linker failed. And they actually compile it both with G++ and Clang++, which is kind of wild. And then they bake in address sanitizer and they bake in Valgrind into it. So here we go, Tev and Bill. And you can see that rather than getting and poisoned by user and all this stuff, it actually deletes all the stuff that students don't care about, which is really cool. And then they tell you, like on this line right here, and then they have a Python exception because they actually bake a Python interpreter into your program whose only job is to look at the output of address sanitizer and to change it into something readable. It doesn't really work that well on C++. And so you can see here, we encountered a Python exception because they didn't do it quite right. But assuming that, like, once they get it working, it'll say, hey, your array is only size, in this case, like 5. You're accessing element 100. Don't do that. And so it's pretty cool. So if you guys want, you can, this is experimental, but it's called DCC++. And it might give you better diagnostics when your stuff breaks. So you can give that a shot if you want. So it's not, like I said, their C++ support is experimental. They teach C as a first semester class, for better or worse. Not really C++. So I expect it'll get better in the future, though. So here we go. So let's get rid of that. So now we're gonna do our thing. Okay. So the label, we just want the label to be like toString main.add0. Okay. And so we want the label to be the first letter of our name. And then, like I was saying, the right way you should approach writing code is to write a little bit of code at a time and then test it. So I could go into like building the whole tree. I'm just going to test this code with just the first node. And I just want to see, does this work? Okay. So that was my old one from the 12 o'clock section. So here we go. Look at that beautiful tree. There it is. What a great tree that is. It's amazing. Almost there. We just need to build the rest of it. Okay. There it is. But this is how you should be developing. Like I said, when students try doing everything at once and it doesn't work, they just start changing random parts and they don't really have a great plan to attack the problem. You want to take the problem, break it down into steps, solve a little bit of that first step even, and test it and work on it. And that's why I'm kind of going through what I'm showing you right now, is because this is how I would literally do your part 2 homework assignment. It's a little bit of time. Nope, that's not it. Then BST. Okay, so now we need to actually do the BST insert. Okay. And scroll that API key off the top. I'll change it in a second. So now we need to do BST insert. Okay. So now we're going to say for int I equals 0. I is less than name dot size, I plus plus. So for every letter in the BST, we're going to insert it into the tree. What's wrong with this? Wait, what's what? What's wrong with this code? What I have so far. Already made the root. Exactly. I need to start at 1. Because if I'm going to insert Bill, if I start at 0, it's going to insert the B a second time. And I could put this code inside the for loop, but I'm not. Because I don't want to have like a special case inside of a for loop. It just seems easier to do it this way. I don't know. It's up to you. For our project, okay, all right. So we're going to grab a character. Okay, so what we're going to do is we are going to make a new BST element and YYP, and this will be called the new guy. And we're going to make a new guy, and he's going to be holding the ith characters. The first time through, it'll hold the I, then it'll hold the L, then it'll hold the L. And now we're going to do a BST insert right here. We're not even doing a function call. We're just going to do it all in main, because why not? Okay, so we're going to make an auto pointer temp equals to root while temp. Simple way of checking for null. Inside of here, temp can never be null unless we change it. Right? So it's oftentimes helpful to write down your invariants, because if I say while temp, if temp is ever null, null is false and will break out of the loop. It only checks it at the top, right? So if down here somewhere I say like temp, if I ever set temp equal to null down here, then it certainly can be null. But unless we change it, temp is not going to be null ever. And so we don't have to check for it. Okay. So we got our tree, our beautiful tree here with a B in it, and we're going to insert an A. Let's say the next letter we're inserting is an A. What do we do? We got a new node. It's got A. We got a root. It's got B. What's the first thing we should check for? Yes. Comparisons. Which comparison should we do first? Equal than, less than, or greater than? We don't actually need to check root, because temp's going to be moving down the tree, right? So temp starts at root, but then temp's going to iterate down the tree until we find an open spot. So root will never appear in our code since after this one. So all right, let's do a equals. So if new guy points to get key equals temp points to get key. What do we do? What if we got a duplicate? What do we do? Die? Seems a little harsh. Pass? Nothing? So what do I type if I wanted to do nothing? Semicolon? Does that work? Break? Return? If we break, yeah, seems like a good idea. That'll break us out of the while loop. Come down here, comes back up to the top of the thing, and it does a new thing again. One thing I would probably recommend, actually, if you're going to do this, is to delete a new guy, maybe, because he's not going to be part of the tree, right? So you should probably delete him before moving on, because we're about to allocate a new one, right? This will stop a memory leak. Okay. If you do continue, then the continue jumps up to here, and temp is still not null, and then it'll come down here and continue and come back here, and you'll infinite loop if you have a continue. You have to break out of the while loop, because it breaks out of the innermost loop that you're in. It does not break out of the for loop, it breaks out of the while loop. And then it'll go back up. When you hit break, it jumps to here. Right there. And then it jumps back up to here. It does the next letter. Cool. All right, so next, let's do, I don't know, less than. So if, let's YYP this, YY, P. So if our key is less than the value that we're currently looking at, which way do we go, left or right? Left. Okay. So there's two possibilities. There's somebody there already, or there's not somebody there. So if you want to check if somebody's there, if new guy points to get left is null, means we found an open spot, and then we're going to put something in, right? So we're going to say new guy points to set left. It's equal to new. No, backwards. Temp points to set left new guy. That'll actually be a good bug for Wednesday. On Wednesday, by the way, you're going to be given broken BST code, and you're going to have to test it to find out what the problems are and fix it. So stay tuned for that on Wednesday. Mick Riley and I are going to make a bunch of broken implementations, and yeah, because this is actually something I got from 60. They're like, that's a, you know, if you give them broken code and they have to like make their own test cases and debug it. Where does get key come from? Love that for us. Yeah, they're helping you guys out. It's actually a good exercise. It's actually a really good exercise to learn how to write tests and to throw tests at code and see what breaks. You know, it's actually a really good thing. It was not the Bridges guys. This was the dive into systems people. So West Point and Swarthmore. West Point knows how to throw things. I don't know. Okay. Get key, get left, get key. Yeah, so get key gets the value, and get left gets the left pointer, and set left sets the left pointer. And if you're wondering, how did I get that stuff? Well, look at this. That's why I left that code in there. So that I know what the name of those functions are. And if I could have, it didn't tell me get left, but because I saw set left, I knew what get left would be, right? Because this is clearly camel case. I personally use snake case. Snake case looks like this. Bridges people use camel case. Again, this is not something that I'm going to get upset about. It's like, despite me every so often throwing shit on people, very, very rarely throwing shit on people, things like this don't bother me in the slightest. So they use, and I can just guess from the fact they're consistent with their style that if they have a set left function, the get left is going to be called this. And if I wanted, I could simplify this down to this. Like that. And that's the same thing. Okay, so we're gonna set left, and then what's the last thing we have to do? So the new guy has been attached to the left. So if we inserted A would appear here. So what do we do now? Delete new dude? No. New guy just got added into the data structure. You don't want to delete it, because then you're gonna have a dangling pointer. You have a pointer pointing at something that's been deleted. That guy has to stay in there until the whole tree goes away. The only reason why we deleted new guy here is because he's not getting added to the data structure. So what do we do next? Break. Boom. There it is. And then if there is somebody there, what do we do? So if we had an A here already, then temp is just going to move down to point to A and repeat. So we're to say temp is equal to temp points to get left. All right. And then we can just shift V for block line copy mode, Y to copy, P to paste, D $sign to erase to the end of the line, else open bracket, and there we go. So that should be our code. All right, let's test it. Actually, let me break it first. There. So teach you guys how to test a little bit. Prep you up for Wednesday. Please enter your name. BA. Okay. And so we come over here, actually just refresh this. You can see we now have a tree with B as the root, A is the left child. Cool. Neat. All right. So let's run it again. BAC. Cool. There we go. Here's our tree. It's coming along. Run it again, BACD. Infinite loop. Okay? This is the kind of testing you have to do. You have to throw, like you start with just one, you start with some more, and then get into it, and you want to exercise every combination of if and else that is out there. And so what happened was we don't have any ability to go to the right. So what's happening, it starts here, we try inserting D. D is greater than B, temp points to here. D is greater than C, it tries moving to the right, and it can't because there's no move to the right code. So we need to put that in. And that, my friends, is fully functional Dungeon Delve Part 2 code. I say before I test it. That's probably right. And there you go. That's what you need to insert. Or that's what you need to submit on Canvas. Okay. Make a dungeon with your name in it. So if my name is Parmesan, did I spell that wrong? I think I spelled it wrong. Then come in here, and you can see P-A-R-M, Parmesan. I don't know. Okay, so the second A is getting deleted. Second E is getting deleted. Parm. Okay, that looks good. So you see how that works? And you submit that. It's 5 points. Call it a day. Okay. Parmesan. Just copy it from Cunningham. There you go. Capital S Parmesan. This one looks a little different, right? Because it's lowercase p. These are the ASCII values or something. I don't know. Oh, we're not setting the labels? Yeah, we need to do that. Okay. Here. So, new guy. Set label. There you go. Always test your code, even when you think it's right. Especially when you think it's right. That's when they get you. All right. So P. Yeah. So these are the ASCII codes, which is kind of funny, actually. 1, 1, 3. A is to the left of P. R is to the right of P. M is to the right of A. E is to the left of M, and to the right of A, and to the left of P. So there you go. Have a little cool. Do this. Do this with your name. Do it with your name. So submit a dungeon with your name as the secret code. Okay. So that is a Bridges implementation that will visualize the data structure, and that's really what Bridges is about. And if I do something like really wrong, like I don't know, something like this. So I'm setting the right child to be the root. Something. B-A-D. Segfault, coordinate. You're getting memory. Of course, you're getting memory leak. It's really funny when students tell me this code has a memory leak in it. I didn't write a. What did I do here? Set it to new guy. I didn't write a destructor, right? This is just building the code, right? So if you compile the code and you're getting memory leak, yeah, of course it is. Code still works. Memory leaks are not the worst thing in the world. They're bad, but they're not the worst thing in the world. Like a segfault's bad. Like it just kills your program. You have an assertion failed in the middle of Skyrim. Boop. Assertion failed. Error 0. Oh, cool. Die. Right? Memory leaks just mean as your program runs, it allocates more and more RAM. You eventually have to quit the program and relaunch it, like you had to do with Firefox for about 20 years. Firefox had a long-running memory leak problem in it, where you just left Mozilla open, Firefox open, and it would just, the memory usage would just go up and up and up, and eventually you'd have to quit Firefox and relaunch it, and now there's no memory leak. So cool, right? It's not the end of the world. It just, eventually it'll exhaust your system memory and crash, but it's a slow burn, and usually you just turn it off and turn it back on again to fix it. So yeah, if you get a memory leak warning, well, yeah, you are leaking memory. Do you need a destructor? I mean, there's no class, right? So you need to, you don't have to delete it. It's probably good practice. And Mincrelli is, I think, probably going to show some code to delete this on tutorial sessions and things like that. But yeah, basically, the best way is to just not run address sanitizer. No problem. If you don't see any problems, there are no problems. Look at that compile time. There you go. Yeah, so we're leaking memory all over the place, right? So my advice to you is to do this. And there you go. Problem solved. Okay. So why is compiling so slow? The bridges headers are kind of big. It's mostly. Also, probably there's people. No. Wow, look at Hansen. Dang, dude. All right. No chill on that one. Okay. Well, I will put it up one more time, but you can also just watch the recording for this. Or if you just need help, just message me your code. This is a fully functional insert. We haven't done a destructor, we haven't done a search, we haven't done a delete on a node, any of that stuff. But this is a functioning insert, tree building, code. No class even. No tree class, just just basically linking the BST elements together in a tree. Is there another Hansen? I think there's two. Yeah, there's two here. Okay, so that is our class for today. You're going to submit your visualization of your name on Canvas. That's due on Friday. I'm going to run the grader for Dungeon Delve right now for part 1, and then we'll be done with Dungeon Delve, and we're going to be moving on to a fun debugging exercise on Wednesday. All right, so what was the bridges include again? It's up top here. It's I think their code was double quote, but on our system it's a angle bracket, so you can use either. Technically, it'll work. Okay, yeah, double quote. I mean, it's not going to break if you had a double quote. Double quote searches both in system directories and in the your directories and in whatever path you provide. New API key is generated, so don't get too excited with my password being on the screen there. Comparison of signed and unsigned, not a big deal. Don't worry about that one. That signed and unsigned comparison is sometimes a big deal, but in a case like that, it's only going to cause a problem if your name is 2 billion letters long, which is dubious. It's probably not, your name's probably not 2 billion letters long, so you're probably fine. If you want to run your code without address sanitizer, it is /G++. Backslash, not front slash, backslash G++. And then it won't turn address sanitizer on for you by default. Okay, that's it for today, guys. Hope you had fun. And that's it, /G++, exactly. Okay, hope you guys had fun. And I'll see you guys on Wednesday. Peace.